we are discussing measures of dispersion. We have two types of measures of dispersion: absolute measures of dispersion and relative measures. We have already studied range and quartile deviation. So even though we have mean deviation in between, that's not so much important. So I'm skipping to the fourth one called standard deviation. The standard deviation is very well used measure of dispersion. So try to understand this. There is a relationship between variance and the new term called variance and standard deviation. So ST is equal to root over variance. Square root of variance is called ST. So before discussing this, I said you that mean is indicated with x bar. So similarly, we write variance with V of x. We call V of x as the variance, which is the symbol for variance of x. To calculate standard deviation, you should first of all calculate variance. Then if you take this positive square root of variance, that represents the standard deviation. Again I am repeating, standard deviation is always dependent on variance, where square root of variance gives the standard deviation. Likewise, x bar used for mean, V of x represents the notation for variance of x. V of x formula is nothing but 1 by n sigma xi minus x bar whole square. This is, I think you have no f's and small n we have. This is for ungrouped data. So if it is for the grouped data, as I said to you that in place of small n you will get capital N, sigma fi into xi minus x bar whole square. This is for grouped data. Okay, the formula for x bar is nothing but here 1 by n sigma fi xi. If we see if it is grouped data, if it is ungrouped data, you know sigma xi by n. So variance of x is denoted with V of x. Standard deviation is nothing but positive square root of variance. Formula for variance is again you will have for grouped and ungrouped data. For ungrouped data 1 by n sigma xi minus x bar whole square. If it is for grouped data, in place of small n you will get capital N 1 by n sigma fi into xi minus x bar whole square, where x bar is nothing but 1 by. So let us do a small derivation on variance. So I think this is the first theorem for you. Show that we know that variance of x is 1 by n sigma xi minus x bar whole square. So you need to show 1 by n. So try to identify the difference. Variance of x is, we wrote the formula 1 by n sigma, we have bracket out before this sigma xi minus x bar. This is equivalent to 1 by n. If you observe here, the sigma is and 1 by n are for only for the first term, 1 by n sigma xi square minus x bar square. So this is the original formula. You need to derive an equivalent formula for variance of x in this way. So what is the formula for variance of x? 1 by n sigma xi minus x bar. You have this one by original formula. So if you observe here, it is in the form of here a minus b whole square. So put the 1 by n sigma you write as it is. Try to expand this using the identity a minus b whole square. A square plus b square minus 2ab. Okay, 1 by n. So as you have sigma in front of this bracket, the sigma is for the first term, second term, also for the third term. So I am applying this sigma to each and every term. Sigma x bar square minus sigma 2xi x bar. So try to understand one thing, that always sigma runs on the variable I. Okay, again just a simple one which we are going to use for a number of times. I think you know about derivative. Okay, I think while writing the derivative in mathematics, you will write d by dx, means here you are finding the derivative with respect to x. So if I write d by dx of 2x, I think as you are finding derivative with respect to x, Here 2 is a constant. You will take out of the derivative, you will write d by dx of x. And you will do your usual derivative. Similarly, why I am taking this example is, likewise derivative, sigma is also an operator. Okay, if you are going to find out derivative with respect to y, all other variables are considered as constants. Similarly, if you observe here, you have sigma like derivative. It always, if I write, whether I write or not, it always runs on the variable called I is equal to 1 to n. So if even though I am not writing I is equal to 1 to 1 here, obviously it always runs on I. So likewise derivative, it is also an operator. So you can take out the terms which are independent of I. So if you observe I here, you have I here 1 by n. Okay, so you cannot take any terms out of the sigma here, as this term involves I. Again, one more thing, I is always attached as a suffix. Okay, xi, yi, zi. You won't get x into I. Xi means it is called a suffix, not x into I. So the first term is involving I. The second term, if you observe, x bar doesn't involve I. So take it out of the sigma, right? If you take out x bar, you will be with 1. So here in this term 2xi x bar, the sigma is on I. So there is no I in 2, there is no I in x bar. So you can take out 2x bar sigma xi. Okay, this is nothing but 1 by n sigma xi square. Okay, x bar square. Sigma 1 is always n. Try to remember this. Sigma 1 is always n. Sigma 2 is n. Sigma 3 is n. Whenever you have sigma 1, always that represents n minus 2x bar. Okay, sigma xi. What is the formula for x bar? X bar is nothing but 1 by n sigma xi. So you have sigma xi here. If you cross multiply this, you will get n into x bar is equal to sigma xi. Means here in place of sigma xi, you can simply substitute nx bar. Okay, so I will rewrite the step again here in the next page. You have variance of x is equal to 1 by n sigma xi square plus n into x bar square minus 2 x bar n into x bar. This is the previous step which we wrote, 1 by n sigma xi square plus nx bar square minus 2n x bar square. So if you observe, these two are like terms. You have nx square plus 1x square minus 2nx square. So you will get 1 by n sigma xi square minus nx bar square. This 1 by n is also for the first term as well as for the second term. So you will get 1 by n sigma xi square minus nx bar square by n. So you got 1 by n is equal to sigma xi square minus x bar square. So variance of x has two forms which we have derived this. And what is the original form? 1 by n sigma xi minus x bar whole square. Variance is 1 by n sigma xi minus x bar whole square. On simplification you will get 1 by n sigma xi square minus x bar square. This is the original expression, and using the simplification we got a simplified expression for this, which we use while doing problems. Instead of using this formula, this will be easy for doing problems. Okay, let us do problems in the next class. Thank you.